Ladies and gentlemen, please welcome your host for the evening, Gracie Arenas Strittmatter.
All right, let's put our hands together for Andrew Maximoff and that wonderful pre-show performance. Thank you. And being that he's from Promethean AI, I would say that presentation was fire. That's what I would say. So thank you, Andrew. Appreciate that. Howdy, and welcome to Real Time Live 2022. We are here, you all. It is happening tonight. We're in person. Let's give a round of applause for that. It's hard to believe that it's been 3 years since we've all been celebrating in the same room together. But if it's one thing that we've learned over these last few years, it's to appreciate the things that happen in real time more than ever. Am I right? Am I right? There you go. For those who have been around the block a few times, you know that this is a show where anything can happen. And for those who are new to this experience, welcome and enjoy. You are totally in for a treat. We have a phenomenal show planned for you tonight with our lineup of presenters ready to give you previously unseen views into technologies that are paving the way for our interactive future. Take a moment and get those cell phones out and keep them out. In just a few minutes, I'll share our audience choice voting instructions. And since you have your cell phone handy, it's important for you to know that photography and recording are highly encouraged. Also, cheering, laughing, and all that fun stuff is also highly encouraged at this event. That's right, I like that. This show would not have been possible without the incredible effort and dedication of many people, including this year's Real Time Live Committee, and notably our chair, Yibing Zhang, who is celebrating with us from afar tonight. Yibing, thank you for your time and effort in spearheading a truly wonderful program this year. And a special thanks to Andrew, Mark, and Chem for lending their time and expertise to help every aspect of this program this year be successful as we returned to an on-site presence. Additionally, it is my honor to introduce the newest member of our SIGGRAPH and Real Time Live family, baby Xander, born last Wednesday. Warmest congratulations to Yibing and family, and Xander, we look forward to seeing you on the Real Time Live jury next year, so study up, okay? I'd also like to acknowledge our Smith-Buckland team and the immense support of Brenda and Jenna, Freeman AV, and our longtime partners Brian and John, Joe and the SIGGRAPH Graphics Net team, as well as our conference chair Munu, for helping to bring many facets of this very intricate program to reality. And of course, the 8 pieces that we are celebrating tonight are a result of the deliberations of our remarkable jury. Inigo, Angela, Yosun, Jeremy, Ryan, and Chan. A heartfelt thank you to each and every one of you. Some jurors are present in the house today, while others are joining us live from other parts of the world. And they will be voting for the prestigious Best in Show Award, which will be presented to the winner at the end of this show. Cool. And thank you, the audience, both here and at home, for being here and supporting our show today. You have a very important role to play in the show with the esteemed and challenging, not gonna lie, honor of choosing our Audience Choice Award tonight. Scan the QR code shown or type slido.com in your favorite browser with code 8890540 to bring up the voting form. The link will also be on every slide between each presenter as well. We'll keep this poll open until the end of the show, when we'll run a countdown to let you know when it's time to lock in your vote. You can resubmit your vote as many times as you like up until the clock runs out, so make sure you choose wisely. Speaking of appreciating more things that are happening in real time, let's kick back, have some fun, and get on with the show. And you've been warned, there might be a few real-timely puns along the way. Kicking off the 14th edition of Real Time Live is a showcase of Decima Engine in Horizon Forbidden West. Presenting is Hugh Milan from Guerrilla Games. Hugh is a senior principal programmer working at Guerrilla in Amsterdam. He led the development of the water for Horizon Forbidden West and the indirect lighting for Horizon Zero Dawn. Prior to that, he worked on graphics for Dust 514 for CCP Games and Crackdown for Real Time Worlds. Let's give Hugh a warm welcome to the Real Time Live stage.
Hi, my name's Hugh Milan. I'm a senior principal tech programmer at Guerrilla. For Horizon Forbidden West, we tried to make the most detailed and alive open world ever. This is a debug build, and I'm going to use it to break down some of the features we built to meet that goal. They are realistically dense foliage, interactive worlds, next-gen water, extreme weather and clouds, and flying. So we wanted to render an insane amount of foliage at very high fidelity, showing every individual blade of grass. To get this done at 60 frames per second, we used deferred texturing for all the foliage. This avoids the cost of quad overdraw for layered alpha-tested geometry, which is usually the big bottleneck. So this is Scalpel, which is our in-game GPU profiler, and these are the deferred texturing jobs. They run on ASIC compute, and here you can see them running in parallel with the shadows. And it supported so much foliage that we couldn't place it all by hand. We needed to do it procedurally. So I'm going to toggle the procedurally generated plants off now. There they are. So all this placement is done at runtime. It's a complex set of artist-defined rules that run on the GPU using a specialized virtual machine. Now, going smaller than grass, we have moss. Moss can be painted in real time. Here's what erasing it and repainting it looks like. It's procedurally placed on every asset and follows natural rules, such as favouring the north side of trees. The second goal was interactivity. Now, all plants react to touch. Some plants even have a skeletal physics rig, which is pushed around by entities. This debug view shows the bones. This simulation also runs on the GPU. All the sand and snow in the game deforms. It's a height field simulation. To find what's intersecting the ground, we do a low-res bottom-up render of the entity so it accurately handles everything the characters and the robots can do. We have a dynamic wetness map. Notice how the sand is wet and shiny where the waves are and dries up as they retreat. It's another height field sim. It uses the water mesh so it reacts properly to waves and splashes of any shape. Turning now to the water. The goal for the water was a single continuous system, so that we want the water to change continuously from shallow murky swamps to crystal clear mountain streams with waterfalls to deep dark lakes to wild choppy oceans. But on top of this, the most difficult feature was the 3D overhanging breaking waves. The breaking waves are based on offline Houdini sims which are stitched together at runtime. If you come to the Advances in Real-Time Rendering course tomorrow, I'll teach you all the details. The foam particles you can see just coming up now are what's called shader-generated particles. That is, the pixel shader optionally writes to an append buffer which defines new particle system instances. The bubbles seen on that building over there use the system too. It's used in a lot of other situations as well. Actually, it's really powerful. The flocking behavior of these fish is executed on the GPU and it provides schools with hundreds of fish. They also react to predators and a player. Looking at, we have a second version of the volumetric system for underwater, which accurately simulates absorption and in-scattering for all the different kinds of water in lakes, rivers, and the ocean. And also gives very nice God rays. We have an occlusion system to cut the cost of water rendering. We look at the Fresnel reflection and depth tinting for each water pixel to see how much the underwater content contributes. Pixels where it's insignificant are highlighted here. We treat those parts of the water as opaque, which means some underwater objects are hidden and can be skipped. This is the weather debug window, and I'm going to advance the weather to stormy. Notice how everything reacts. The clouds change, the post-processing, sun brightness and indirect lighting change to match the new weather. Notice how the ocean changed from calm to choppy, there's lots more foam, and there's impact ripples from the rain. Looking now at the materials on Aloy, notice how each material reacts appropriately to wetness. Some turn dark and shiny, others are droplets. Moving in close, you can see water droplets on Aloy's face from the rain. In hot climates, you'll see beads of sweat and her face reddens. Pulling back a bit, in movies, the actors are not lit so much with natural lights, but with carefully placed artificial lights. We have a custom light rig for Aloy that's inspired by that. I'll toggle it now to show what it adds. It adapts to the light color and intensity of the environment, so Aloy is always lit like she's in a movie. The last topic is flying.
Fast flyer too.
Flying means the camera can see the clouds from the inside as well as from far away, and they need to intersect with regular geometry. The clouds are rendered and lit using ray marching, so lots of tricks were needed to make it run in real time without compromising details or quality. And there is the supercell, which is a showcase feature of the cloud tech. To reduce the massive cost of ray marching, it relies heavily on temporal reprojection, which doesn't cope well with abrupt changes. So it was quite a challenge to get it to respond instantly to the lightning flashes. Well, we hope you enjoyed this whirlwind tour of some of the graphics features from our game, with a glimpse of the challenges in making them work all across our huge open world, with all the different biomes and tribes and settlements, and across all scales, from the tiny details like sprigs of moss, all the way to the horizon. If you'd like to know more, there's some talks at the Advances in Real-Time Rendering course tomorrow, and we're always looking for good people to help us push the technology further at our beautiful studio in the centre of Amsterdam. If that sounds like you, then please apply. Thank you very much. That's everything.
Thanks, Hugh. That was a lot of pretty cool engine features. I'm not done yet. I'm not done yet. Audience, do you think that presentation decimated the competition? Only time will tell, because we've still got other presenters on the horizon. Okay, we're good. We're okay. Next up is AI and physics-assisted character pose authoring. Presenting is Florent Bocquelet from Unity Technologies. Florent is machine learning manager at Unity Labs, working on innovative tools to improve 3D character animation workflows. His areas of expertise are machine learning, applied mathematics, and software development. He has also released several games as an independent developer. Please join me in welcoming Florent to the Real-Time Live stage.
Thank you for the introduction, Gracie. My colleagues and I work at Unity Labs on developing machine learning-based tools for content creation. And today I'm going to show you some work we did around character animation. But first, let me show you how posing a character is typically done. So I'm not an artist, I'm not an animator, but I got that character ready for animation, and I'm going to try to make it sit on that chair with the legs crossed. It might be a little painful to watch for animators, sorry. So you can see that there are some controls, and as I manipulate them, the software performs inverse kinematics so that I don't have to pose each individual joint which is convenient, precise, but also you can observe that many of the intermediate poses are not realistic, feels unnatural, or are sometimes impossible for a real human being. In addition, this is typically combined with complex handcrafted constraints, like that foot roll. If I spend enough time on these, I will eventually manage to make that character sit on that chair. But for a beginner like me, this is very time-consuming, and it is still hard to achieve something that looks good. So we developed a tool to make that posing process easier for beginners. This is the exact same character inside our tool. The 4 orange dots that you see on the hands and feet are input position to a machine learning model that predicts the full pose of a character up to individual fingers. You can see that as I manipulate those controls around, the intermediate poses keeps being balanced and natural, and this is because our model was trained on motion capture data. One thing we really wanted to enable is to let users specify constraints in any order and number. So I can, for instance, remove a constraint on the right hand and on the left feet, and pose that entire character from only 2 points. Then I can refine the pose by adding more constraints, for instance, on the knee, and so on. We also support other types of constraints. For instance, rotational constraints that specify the global orientation that a joint should have. One nice thing is that orientation and position constraints are independent from each other. So I can ask for a specific orientation of the hand, but let the model figure out its position. We also support look-at constraints, which are a target at which the character should be looking. Okay, let me show you something interesting with that one. I'm going to remove the rotation constraints on the chest and hand. I'm going to free the left hand, pin the feet, and make the character sit on the ground. You can see that as I manipulate the target around, this has a very broad impact on the overall pose to keep it natural. Okay, let's try to pose that character on that chair again. So this is the same chair, and I'm bringing a new character. I'll move it closer. We combine our tool with a physics solver so that it is easier to pose character interacting with the environment or with themselves. For instance, like when crossing the legs. I'm going to make the hand a bit closer, have it look in front, move the hand, maybe like so. And you can see that it took me only a few manipulations to make a quite convincing sitting pose. We also combine our technique with standard retargeting tools. So you can use the same machine learning model on a character with a totally different skeleton topology or morphology, like that complex character. I'm going to try to pose those two interacting a bit together. So I will make that one sit next to the other one. Maybe a bit lower, like so. Have them look at each other. Getting interesting, I see. Not sure if it's a hug or a kill move. A little too far. Maybe like that. I'm going to move the other hand closer. And next time I will ask you what I should do. You think it's a good? Maybe a deeper look, like that. You can already tell there is a story between those two characters. If you have training data for it, you can also train the same model on any kind of character, like that dog. And you will still benefit from similar controls, like the look at, and so on. One of my favorite things to do is to make the dog roll on the ground just by specifying the orientation of the chest. And then we can make it look at our two characters. And here you go. You can see that in a few minutes, I was able to create a convincing scene, even if I am not an artist myself. Thank you for your attention.
Thanks, Florent, for exposing us to that amazing time-saving technology. I don't think anyone would be opposed to doing animation work after seeing that straightforward decomposition of that incredible tech. Next up is hybrid VR desktop sculpting with Adobe Substance 3D Modeler. Presenting is Giovanni Nakpil and Anton Mikolov from Adobe. Giovanni is a senior design evangelist and creative director at Adobe. He is deeply influenced by the magic of sci-fi and horror films. His multidisciplinary interests have led him to explore roles including digital model supervisor at Industrial Light and Magic, 3D artist at Valve, and art director at Facebook. Anton is a lead UI architect on Adobe's new creative tool, Substance 3D Modeler. His passion is in maximizing the bandwidth of human-computer interaction, in particular for artistic use. Anton started his career at PlayStation R&D, where he worked on developing novel interaction methods and devices, most notably the Move 6 Degree of Freedom controllers and the PSVR headset. He later joined Media Molecule to help capitalize on these technologies for the creative game Dreams, for which he designed and implemented the 3D tools and interactions. After his kids go to bed, Anton practices martial arts and tinkers with artificial life. Let's welcome Giovanni and Anton to the Real-Time Live stage.
All right, hi everyone. So today we'd like to show you a quick demo of our new tool, Substance 3D Modeler, which is out in beta. So Modeler is a volumetric program, so you can see Gio here is making some brushes that are 3D primitives, and the primitives have lots of parameters he can tweak, so you can quickly make these shapes like a tapered box and add chamfering. And with these 3D brushes, he can sketch forms just like he would with a 2D brush in something like Photoshop. This way of thinking about shape lets you work without worrying about topology or interacting with triangles directly, so it's just much more of a volumetric shape-based way of thinking rather than thinking about the surface. And all of these different edits are going into separate layers, so you can separate your model based on kind of the content, and then you can take these layers, you can duplicate them and reuse them to rapidly build up the content that you're seeing here. And so in addition to additive, of course, we have subtractive edits as well. So here he's going to add some detail to the column by doing some radial symmetry, and then dragging that out to make some divots in the column. And because it's in a separate layer, he doesn't have to worry about that capsule cutting away other parts of the geometry. And one important thing about modelers, so far Gio's been using a mouse, but for a surface detail, it's really nice to be able to use a tablet. So you can actually switch directly into using a tablet. So whereas mouse is very good for precision, kind of hard surface, and that kind of architectural modeling, the tablet is really good for free-form hand gestural decoration. So, like other 3D software that uses these things, it's really great for surface manipulation. So it's a good way to add detail to your surface. But with Modeler, we try to support a broad range of devices. So in addition to supporting tablets, we support VR as well. So if you want a full free-form experience, nothing really beats a spatial controller. So you can grab and pull things in direct 3D. So Modeler switches interactively into a VR system. So you just put the headset on. Just like you pick up a pen, you can pick up your headset and jump right in. So really, it's about using all these different devices as part of your workflow, even switching between them in the middle of your workflow to see which one fits your purpose better. So in this case, it's really easy with a full 3D hand to mold these shapes directly to the pot since it's an uneven surface. But even while you're in this freeform mode, you still have access to your precision tools like the gizmo. So if you need to do something exact, like making that rim go, down exactly down the axis of the object, you can still get those tools. So you don't have to jump between the different modes if you don't want to, but you can stay in one, or you can choose on the fly which one you're interested in. And the UI is identical between all the different modes. So once you learn one bit of UI, you can jump between VR and not be, it won't be alien to you. So here he's starting off another radial symmetry, so you can have unique symmetry configurations per each layer or per group. And so you do a little bit of precision machining using the symmetry and adding this pattern, and then he's able to freeform drag it onto the surface, then again invoke some more symmetry to get it onto the pot, and then finalize it by warping it into shape. So it's a really great way to blend handcrafted artistic parts of your flow with procedural replication as well as precision machining. Okay, so that's good for the pot. Now we're gonna make a plant for it. And so using the same methods as you've seen already, so just additive and subtractive tools, Geo's able to take these primitives, these egg-shaped primitives, and use them in a clever way to create a petal for a succulent plant that we're gonna be making. So you take an egg, just subtract another egg. And because you've got this full 3D control, it's very easy to create these organic shapes and then smooth bits of them out using the smoothing tools. He's also able to duplicate layers, and that way he can morph them on top of each other, sort of echo these forms. He can take those together, really quickly merge them, smooth them out to get a little bit more form, and then add some thorns on it so that he can turn it into like a cactus shape. Or he can also radially repeat it to get a nice bud going off of it. And you can even edit it after the repetition. You can see if he's adding the thorns in now, they're replicated across all the other copies. You could also copy them and the symmetry settings persist, so you can quickly build up this shape. You can then group the shape and make it a reusable module. So Modeler supports instancing for layers and also entire groups. You can take it and very quickly copy these things. They don't cost you any memory. And with VR, it's really rapid to be able to place these things in a free-form way. You can even multi-select them and just populate this pot really quickly. And since they're all instanced, if you edit one of them, all of them will update in real time. So it's all non-destructive. And there's not like a main one, so you can actually just grab any one of them. You can even reparent them dynamically without, just directly in the viewport without messing with a scene graph. And you can see that now, because it was added to the parent of that group, it's now radially repeated as well. So you might wonder then, what would happen if you parent an instance to itself? And in that case, you actually get this wonderful recursive structure. So instead of crashing, we sort of curb the recursion by scaling the objects for every iteration. And that allows you to make these cool fractal shapes, or you might say fractus shapes. And the neat thing about that is, of course, it wouldn't be SIGGRAPH without a teapot joke at the end. So thank you very much.
Thank you, Giovanni and Anton. That presentation really had a lot of great substance, don't you think? Sorry. Oh my goodness. Y'all really killed it with that pottery demo. And audience, I don't know about you, but that plant virtually grew in front of my eyes. That was pretty cool. Next up is behind the scenes of the Cavern Unreal 5 Cinematic Visual Tech Test. Presenting is Colin Penty from the Coalition. Colin has worked at the Coalition 11 years, most recently supporting Epic with shipping The Matrix Awakens, a UE5 experience on Xbox. Prior to that, Colin shipped Gears 5 and Gears of War 4 as a technical art director. He was previously at EA for 7 years on Need for Speed, Skate, and FIFA. Please join me in welcoming Colin to the Real-Time Live stage.
Hi, everybody. Thanks, Gracie. So I'm showing you guys a cinematic visual tech test that we created for Xbox Series X, sort of push the visual fidelity of Unreal Engine 5, evaluate our pipelines and workflows, and basically just see how it would run on Xbox Series X. This first debuted at the UE5 State of Play stream a few months ago, and today I'm going to show you the full demo. So I can pause here at any time and basically go around, look at the character. So you can see here we have the 4K textures that we're leveraging using Unreal Engine 5's virtual texture system, which has about 0.2 milliseconds overhead on the CPU. So this really allows us to push the texture fidelity higher than we ever had before. The face here is about 31,000 triangles, a lot higher than what we've had in the past. So if I go here, I can basically zoom in on the character. Oops. I can go up and look in, and we have the groom assets. So if I can toggle the groom assets off and on here. And so the groom assets on this character is really one of the biggest jumps for fidelity for us. It's about 3.5 million triangles for the groom assets. One stat that was particularly, that really stood out to me was the eyelashes are about 3,500 triangles, or about the entire triangle budget of an Xbox 360 character, just in the eyelashes, which is pretty awesome. So unpause it here. So you can see here we have some cloth sim happening of chaos cloth in our proprietary raw dynamics system. We have the smoke monster here, which is essentially a sub-UV particle system. You can zoom in on the face here. So the character's face, the eyes, and the mouth are from MetaHumans. We grabbed MetaHuman pieces where it made sense, and the rest was built in a DCC package. We also sort of leveraged the MetaHuman skin shader and modified it slightly. I can hit R here on the keyboard, and that lets me visualize the blending regions. There's 12 blending regions. So you can see them all kicking in here as he looks around. So I'll turn off that blend mode. And so here, if I look at the character, we're leveraging UE5's control rig. And so control rig here, what we've done is our control rig controls the morph targets, the pose asset driven transforms, and the shader parameters for wrinkles. What was, I think, quite cool is we used Python to auto-generate the control rig, so we could just iterate on it as we see fit. And yeah, we have 321 blend shapes and 158 joints. Here you can see the environment. Just take a moment to talk about the environment here. So the average asset here was about 300,000 triangles. We've since gone to the millions. We found with this demo that we were having trouble UVing assets that were in the millions. We've since found tools like Rhizome UV has really helped us with UVing assets that are in the millions. I can toggle nanite assets on and off. So that's nanite assets off, nanite assets on. You can see like the ground here, you'd be like, why is this not a nanite asset? We were using things like pixel depth offset to blend the sand in with the bricks seamlessly, and that at the time of this demo, that wasn't supported with nanite. I think it's since been added. So you can see the body here is about 160,000 triangles, about 3x what we used on previous gen. What else can I say about the body here? The mesh is it's a skeletal mesh, so we don't get the nanite acceleration with skeletal meshes. That also means we don't get the virtual shadow acceleration, but that's okay. It's worth it. You know, looks amazing still. The performance capture was all the body motion was captured in our studio at a mocap stage in our studio, and then the facial and audio was captured in a soundstage in LA. And we put them together using cubic motion.
Is that all you got?
You want the challenge.
I want to get out of here.
Just pause for a second here too. And we also implemented a bidirectional cinematic pipeline. And this is really useful because this allowed us to record animation through LiveLink in the editor, edit the timing of the raw animation in Sequencer in Unreal Engine 5, do the layouts, the cuts, and then we would export that back into Maya and put that on our custom rigs and refine the animation, and then export that back into Unreal.
Just anywhere but here.
As you wish.
let's take a final moment here to say, performance-wise, this is all running on Xbox Series X. We're about 22 to 30 FPS range. The most expensive thing here is the groom assets, about 10 milliseconds. It's also self-shadowing. And so we've since found a way to build the groom assets about half the triangle count, maybe 1.75 million, and look just as good. So you kind of have, there's a balance there to be found with the strand counts, etc. Yeah, and so I should say a few things like this is a tech test and not representative of a game product. And shout out to the Realization Group, the art directors, Tech Art, for putting together this cinematic. And yeah, Xbox is hiring. And yeah, if you want to join our team, come see us at the booth 843. Thanks.
Thanks, Colin. What do you think, audience? Did that demo cast a shadow monster on the competition? I don't know. You think do you think it'll cavern the most votes and be the most popular? I don't know. We gotta wait and see. We're halfway through our demos. Next up is the Hyper Drumhead, a musical instrument for the audio-visual manipulation of sound waves. Presenting are Victor Zappi and Mike Frangel from Northeastern University. Victor is an assistant professor of music technology at Northeastern University. Being both an engineer and a musician, he focuses on the design and the use of new interfaces for musical expression. His research interests span virtual reality, physical modeling synthesis, music perception and cognition, and music pedagogy. Mike is a composer, performer, researcher, software developer, and educator. He is currently on the faculty of the music department at Northeastern University, where he teaches courses in music technology. He is also founder of Boom Audio Technologies, LLC, a company devoted to bringing high-quality audio software to market. Let's welcome Victor and Mike to the Real-Time Live stage.
Hello, everyone. This is a Hyper Drumhead, a novel musical instrument, and to understand how it works, we're going to first talk a little bit about acoustics. So every time we hit an object, a wave starts propagating from the hit location, and the surface of the object is slightly deflected. These waves propagate across the whole body of the object and eventually travel through air and reach our ears so that we can hear it as sound. And this acoustic phenomenon is shared across the design of most percussion musical instruments, and it is exactly what the Hyper Drumhead simulates in real time. So every time I touch the surface of the instrument, some waves start propagating, and I can change the shape of the surface, and I can appreciate how this affects the sound in real time. I can also modify the virtual material the surface is composed of. For example, I can make it more resonant. Or I can change the speed at which the wave propagates through the material itself. So basically, the Hyper Drumhead allows me to create virtual percussion instruments, displace them on its surface, and I can then save them into presets and recall them for later. For example, here I have a bunch of drums, a gong, and some cymbals. Other than surface tapping, the instrument allows for a second type of excitation, which consists of continuously injecting audio files into its surface. For example, here I have a cello. And this allows me to explore the resonances that are created by the space, and I can also modify the material as I showed you earlier. So how does it work? We split the domain into a grid, and we use a finite difference time domain scheme to compute the next displacement value across all the points of this grid. And in particular, we use this simple formula here that shows how the next displacement value here in blue depends on the current one here in orange, and as well as on the previous one in purple. And all the values of the four neighbors here with the yellow subscripts. The actual solver is implemented as an OpenGL shader, which computes the next displacement values and stores them into the fragments of a texture, which is eventually what we see on the surface of the instrument. This is how the texture looks like. It is big enough to contain 2 copies, exact copies of the domain, one for the current time step, the other one for the previous time step. And this allows the shader to have access to all the data that it needs to compute all the displacement values across the full domain. And this happens in parallel on the GPU the computer is equipped with. If you can see here, there is an extra portion of the texture in green. This is a buffer where the audio coming from the virtual microphones that are displaced on the surface of the instrument where the audio picked up by these microphones is stored and before being shipped to the audio interface. And here I have a debug version of the application where we can see the full size of the texture. And if we look closely here at the bottom, we can see the audio buffer being filled with the waves that are picked up by the virtual microphone that is here. So now we're going to play a short piece in which I'm going to show you a third excitation modality, which consists of injecting live inputs into the surface of the instrument. In particular, we're going to inject Mike's guitar into 3 areas here, here at the bottom, and here, as well as here at the top. While here, I'm going to process in real time a drum loop. I hope you enjoy it. Thank you.
Thank you, Victor and Mike. That one really marched to the beat of a different drum. Audience, did the hyper drum head ensnare your vote? I don't know, might have. We'll see. We've got 3 more pieces left. Next up is real-time technologies for realistic digital humans, facial performance and hair simulation. Presenting are Krasimir Nichevsky and Daniel Gajo from Unity Technologies. Krasimir is a game industry professional with a passion for innovation, cinematography, animation, tech art, tools, and pipelines. He has been animation director for Unity's demo team since 2015, with projects including Adam, Book of the Dead, The Heretic, and Enemies. Previously, he was a lead animator at Crytek. Daniel has been a VFX Swiss Army knife for over 20 years, learning how to push the artistic and tech boundaries in real time, and still faster than a herring. Please join me in welcoming Krasimir and Daniel to the Real-Time Live stage.
Hi, I'm Krasi. Together with Daniel, we'll show you some new real-time facial animation hair simulation tech. A few months ago, we released our latest project, Enemies, featuring Louise, a digital human. In order to get the highest possible quality for her facial performance, we decided to use 4D. But what you're looking at now is the evolved version of the character. There is no 4D here. It uses the Ziver RT facial animation system, which has a brand new concept that instead of blend shapes, uses machine learning to train a digital puppet with some very unique features. First of all, the size of the puppet is just 50 megabytes. And it's also faster than a computational rig. The interesting thing here is that Puppet is also interactive. With these expression controls, we can alter the performance in a lot of ways. Let's get close and see what we can do. Let's add a smile to her. I'm picking the smile control and then pick a number that makes more sense, and let's look at the performance again. The extraordinary thing here is that these are not blend shapes that are mixed on top of the performance. The puppet is actually showing phonemes and expressions that it was trained on. One could say that we are controlling Anne's mood by drifting her performance through different data sets, happy, sad, and so on. That's why it feels so organic even when she speaks. It gets even better. The puppets are compatible with each other. Let me introduce you to Emma. Emma is the puppet, one of the first puppets that Ziva created. And since the puppets share the same parameter space, we can actually transfer Louise's performance onto Emma. Basically, Emma gets possessed by Louise. Her puppet is now being driven by Louise's performance and reenacts it in her own way. We can also change the performance as before by using the controls. Let's add again a smile. And the puppet will have a smile all the time. But we can also do something different. We could boost the performance that's already there. Let's go to a place where there's a smile and we can add a multiplier. This multiplier will boost all the smiles in the performance. So she will now smile more. Sorry, my screen went off. Okay, let's move to the backup computer. Okay, so now we can boost the smile as before. And the puppet will perform with a bigger smile this time. Or we can also remove the smile as a whole, which is pretty crazy. If the multiplier is 0, she will talk again without smiling at all. The things we can do with these controls are quite amazing. Let me show you a bit more range of the rig. It looks like a normal rig, but it's actually just made in a way that it feels familiar. The rig itself is trained, and you can train it to be simpler or more complex. And whatever you do, the rig will try to achieve the realistic result as possible. This allows for a non-destructive workflow that can even be used procedurally at runtime. Also, what I can do is not limited to controls really. For example, I can add any arbitrary deformation and the rig will try to accommodate it without destroying the character. I prepared this sine wave here, which will add something like wind. You can add jiggle effects and stuff like this. And all of this freedom is at the cost of 250 floats. That's insane. I've never seen anything like this. That's it from me. Now it's Daniel's turn.
Hi. Thank you, Krasi. Hello, my name is Daniel Gaggio, and I would like to present you the strand-based system that we developed during the Enemies demo. I have here the same character that you just saw. So let's look at her groom and play around with it. We can adjust, for example, the cluster behavior. We can also change the stiffness. Or the gravity. This is a very powerful system able to simulate millions of strands in real time. And it will work with grooms that are authored in pretty much any package that can export alembics. But if you want to author the hair procedurally, you can do that directly in Engine. Like if you want to make a fluffy teddy bear or this dog, for example. Here it's possible to make the strands shorter. Or longer. Straight. Or curly. Take a look at the interaction between the comb and the strands. It leaves those trails because the strands are very, very soft. But we can adjust that by increasing the stiffness. Okay. The final thing I would like to show you is how the system scales. Here we have a very simple setup. It's a plane with a hair system attached to it. I'm now changing the LOD values. And as you can see, the simulation will adjust as well. Right now, we're simulating just 1% of the strands, yet the simulation is maintaining a very similar behavior. This is really important when you have many characters in your scene, or of course, if you target mobile platforms. And that's because the system is built around scalability. We just made this hair solution publicly available, and you're welcome to see it in action at the Unity booth. Thank you.
Thanks, Krasimir and Daniel. And I have to say, you showed a lot of hairstyling grace with what happened on stage, so well done. I know that's why we're here. That's why it's real-time live. That's why it's exciting. So that does tend to happen. All right, so for me, that presentation had a lot of freedom of expression, so I respect that. And I personally found it hair-raising and quite emotional, don't you think? All right, so next up is instant neural radiance fields. Presenting are Isaac Deutsch and Alex Evans from NVIDIA. Isaac is a research scientist and software engineer at NVIDIA, working on 3D reconstruction applications. He has a background in robotics and mechanical engineering. As such, he is passionate not just about synthetic simulations, but also about edge computing on real systems and connecting the two. Alex joined NVIDIA in 2020 after a long career in games. As co-founder and technical director of Media Molecule, he worked on creative gaming, releasing Little Big Planet and Dreams. He's interested in alternative representations for microgeometry and anything that lies at the intersection of computer graphics and tools to empower artists. Let's welcome Isaac and Alex to the Real-Time Live stage.
Hello, everybody. Unless you've been under a rock, you probably have heard of NeRFs, which are so hot right now. And neural graphics are sweeping through our community. And here you can see something quite cool, which is a NeRF being rendered in a prototype kind of proof of concept that we have in NVIDIA's Omniverse here. And what's cool is that it's able to interact seamlessly with more traditional assets like this beautiful green donut, which is reflecting the Lego digger, and it's also able to be occluded by it and cast shadows and so on. So NeRF is a very kind of powerful new technique where a small neural network is trained to learn a 3D shape of volumetric density and color from images. And our new paper that was presented at this year's SIGGRAPH, Instant Neural Graphics Primitives, has brought the rendering time for these kind of primitives down from a few seconds per frame to a matter of milliseconds. But what I think is even more exciting is that the training time, which was originally a few hours, has now been reduced to a few seconds. In fact, we just trained that from scratch. So Isaac, if you could just reset the training, because I blinked and missed it. So that's trained from scratch to pretty high quality. Now, for any of you out there who've done volumetric rendering, NeRFs are wonderful because they're bringing back volume rendering to real time. And it's a very simple algorithm when you're rendering. But what's cool is that NeRF provides us with inverse rendering. We can create new assets from photographs. So for example, I just casually took my iPhone as I was walking around a building in sunny England, and with a few photographs I was able to recreate this gargoyle as a 3D asset with very little effort. And this is just done with an iPhone, but if you have a bit more time and you're willing to let the model train for perhaps a minute, I should emphasize this is all running in real time, live, of course, on a single RTX 3090 graphics card. So in this case, we trained the model for around a minute, and the quality is extremely nice. And when we saw this, we thought, well, wouldn't it be nice if you could go from waving a camera around to having a reconstructed neural radiance field in a few seconds? And one of the barriers to that is that typically NeRF is trained in batch. You have to go take all of your photographs, then you run them through a system such as Colmap, and then you feed the poses which Colmap has calculated from those photographs to train the NeRF. So what we wanted to show you today was a new system. What we've done is we've taken NVIDIA's real-time SLAM system, and here Isaac is using a Microsoft Kinect depth sensor, which captures both depth and color. And the cool thing is that it gets a great point cloud that you can see on the screen right now, but it has a limited field of view and a relatively kind of short, you can see the shadowing basically behind the objects. So what we do is we fuse multiple frames from the camera by aligning the point clouds every frame by tracking a kind of model to frame correspondence. And we realize that this kind of system effectively annotates each frame from the camera with its position. This is perfect to feed to a NeRF. So in fact, what we're doing right now is training a NeRF before your eyes from this beautiful little still life. And once Isaac has finished the scan, you can allow the model to continue training. And if we were to wait a little bit longer, I think that a lot of detail will come in. In fact, it's still mind-blowing to me that it's actually able to reconstruct the holes in the back side of the bunny through the holes in the front side. After only a few seconds, the reconstruction is looking pretty nice. I'd like to emphasize that NeRF isn't just a surface model. It's actually fully volumetric and view-dependent. So you get a lovely kind of sheen that can move as you move the camera around. And it's particularly strong at these kind of sort of non-surface-like features, such as the flower. Now, this felt a bit too like easy mode, so I'd like to introduce international man of mystery and computer graphics rock star Cem Yüksel, who agreed to be scanned live on stage with his lustrous mane. So please welcome. So neural radiance fields in this form and in the original form assume a completely static scene. So Jem is going to have to stay completely statuesque, which I'm sure he'll be able to do. And when you're ready, Isaac, take it away. Okay. So Isaac is moving in a spiral, and that allows us to capture a fairly nice coverage of the shape. And the wider the spiral, the wider the range of views that we'll be able to render after. So that took all of 5 or 6 seconds, and Jem was admirably still. So you can relax now, Jem. Thank you very much. And you'll be able to see the reflection of his badge. And if we let it train for another minute, I think that you'd find that the detail would fade in and really crisp up on his hair and on the features of his t-shirt. And as you can see, we've actually been able to recreate the 3D model behind as well, which is really nice, even though it was only captured out of the corner of the eye of the camera. Okay, so that's our demo. We're very pleased to be able to present this to you tonight, and I want to thank all my co-authors on the paper and on the NVIDIA Omniverse Slam team. So thank you very much.
All right, Jem, you did a good job holding still. That was a slam dunk, I think. That was pretty good, pretty good. And presenters, I hope you didn't find presenting on stage too nerve-wracking. So. Okay, next up, thank you, appreciate that. Next is Future Stage by Evil Eye Pictures and Patrick Osborne. Presenting are Patrick Osborne, Dan Rosen, and Alistair McLeod from Evil Eye Pictures. Patrick is an award-winning animation and direction supervisor who has worked on Disney's Paperman, won an Academy Award for Disney's Feast, and also received Emmy, Peabody, and Annie Awards for Google's Pearl. He recently directed the Grammy-nominated Billie Eilish concert for film for Disney Plus and an episode of Love, Death, and Robots for Netflix. Dan is co-founder and CEO of Evil Eye Pictures. He has contributed to award-winning feature film visual effects for over 25 years and is currently focused on special projects in real-time animation. Alistair is a motion capture supervisor and software developer who has been working at Evil Eye Pictures since November 2020, developing the Future Stage technology platform. Please join me in welcoming Pat, Dan, and Alistair to the real-time live stage.
All right, hello everyone. Welcome to Future Stage from Evil Eye Pictures. I'm Patrick. On stage with me I have Alistair McLeod, our lead developer on this project, and Dan Rosen, one of the founders of Evil Eye. What we've made here is essentially a system of tools that allows for actors to perform and for that performance to be captured, and they can be anywhere in the world, and it is synced up in the cloud and streamed in real time down into the Unreal Engine to be rendered beautifully and for the world. It's really simple. It's login based. There's no VPNs, no multi-user sessions necessary, and it includes 3 parts really. It has our iOS app called Stage Kit, where the actors perform and where I can actually direct them. It has Stage Control, which is a Windows application where Dan and Alistair can kind of trigger events in the show as the actors perform in real time, and it has a plugin called Stage Link, which is our version of Unreal's Live Link. And Dan and Al, they're on stage with me here, but they can actually be anywhere in the world as well. The system's entirely decentralized. And what this enables is essentially a animated live improv show to happen in real time. So that's what we're gonna put on for you guys right now. This QR code, if you point your phone at there right now, that's going to be our suggestion box. The actors can take suggestions. You can also just shout them out in the room. So literally just shout suggestions out in the room when the actor, when the character on screen asks, and that'll be our show. I'd like to introduce you to our actors real quick, up on screen if I could. So we have Darren Butters in Glendale, California. Wave to them, Darren. And then we have Isabel. She's in Los Angeles. They're in their homes right now, putting on an improv show for you guys. So let's dim the lights and draw the curtain, and we can begin the show.
Vancouver, thank you so much for having us. We're so excited to be here to put on the show for you. An improv show means that it's fully live and improvised from your suggestions. So again, put those suggestions in the hero box and also just shout them out. I already see some suggestions coming in. I see cactus, I see a chunk of cheese. These are great. Sushi, latte. Wow, you guys are really using this suggestion box. We love it. That's what makes it so live and fun. I'm gonna pick a couple here. I'm really liking wedding. That's great. I love wedding. Oh, someone in the theater said hat. I like that a lot. So wedding, hat, and someone said chunk of cheese, which I just thought was great. So let's use chunk of cheese, wedding, and hat. Those will be our 3 suggestions. We'll use those in the scene. I'm going to be a rideshare driver trying to maintain my 5-star review. And getting in the car, let's go. Ooh, big day, big day.
Hi, are you my driver?
I am. I'm Alicia. Oh, big bag.
It's heavy. Sorry.
That was really heavy.
It's going to be okay up there, right? I mean.
Oh yeah, no, it will be totally fine. Where are you going today? Let me plug you in.
Have you ever heard of the pizza party place called Chunk of Cheese?
Have I heard of it? My parents own it. Yeah, let me plug you in.
Good. I love the animated characters and the animatronics and, you know.
Oh. Yeah, no, it's great. And I love that they give out prizes of just a huge slab of cheese. That I love that my parents do that. I grew up eating a lot of cheese.
Do you want to hear a fun fact about Chunk of Cheese?
I obviously do.
I got married. Cheese.
Stop it right now. Stop it right now.
Seriously. I had my wedding at Chunk of Cheese.
Okay, hold on now. Because my wedding cake was just a chunk of cheese.
What?
Yeah, no, I know. It's crazy.
Are you from the country?
Yeah, no, I'm from the country.
Yeah, because, I mean, that hat is a dead giveaway.
No, I know. Look, I'm a farm girl. I've always been a farm girl. So, oh, sorry, sir, your box is shaking.
It's just the wind, probably.
No. Oh, there's a hand. Behind your box. Probably.
We need to get to Chunk of Cheese right now.
No. What are you talking about? No, it's trying to take my hat, I think. Oh, it's gone. It's gone.
Can you stop the car right now?
No, I can't stop the car. I'm going
you must. I need you to please stop the car right now, or I'm going to jump out.
No,
I'm going to jump out. I'm jumping out.
Oh, this is my nightmare.
And take a bow. And that's Future Stage. Come see the panel tomorrow and we can take some questions about it. Thank you very much. See you guys later. Bow again.
All right, thank you, Patrick, Dan, and Alistair. I'd give you a hand, but it seems y'all already had one in that suitcase. So. I don't know about you, audience, but I found that performance uber uplifting. Thank you. Y'all are starting to give me the evil eye on all these puns, so I think it's time to move on. So we'll go on to voting. So massive thank you. First, to all of our contributors this evening. We are honored to have you all here, and all of these achievements are incredible, and they've taken a lot of effort to bring to this stage tonight, so wanted to acknowledge that. So let's give it up to our presenters. So audience and jury, it's time to decide your favorite and lock in your votes now. Scan the QR code shown or type slido.com in your favorite browser. Enter the poll code 8890540 to bring up the voting form and enter your choice. You can change your vote up until the time on the screen runs out, and we'll now have a few minutes for voting. And presenters, may the odds be ever in your favor. All right, our votes are in. Who's going to stake their claim in 2022 real-time fame? So first, we will present the Audience Choice Award. Winners, please make your way to the stage for your award and the opportunity to say a few words. And the 2022 Real-Time Live Audience Choice Award goes to AI and Physics-Assisted Character Pose Authoring.
prepared at all for this, so it's going. Thank you so much for voting for us. Like, thank you very much. It was not expected. Yeah, that's the word. I want to thank the organizer as well. Like, it's amazing to be part of such a great event. Like, SIGGRAPH is amazing, amazing people, amazing things to see. So very happy to be here. And I want to give like big thanks to my team, actually. So Félix Harvey, Boris Orishkin, Louis-Simon Ménard, Béret, Jeremy Coles, and Dominique Laflamme. They are amazing people to work with, and they really deserve that as well. So give them an applause. Thank you very much.
Now, let's move on to the highly anticipated Best in Show Award. Winners, please make your way to the stage for your award and the opportunity to say a few words. And the 2022 Real-Time Live Best in Show Award goes to A Showcase of Decima Engine in Horizon Forbidden West.
Thank you very much. It's amazing to receive this award. There's a lot of people I have to thank. The organisers of all of this, putting this together tonight, thank you very much. A lot of work needed to make this happen. Need to say thanks to a couple of the people who helped put this demo together, which we've all seen. Brian Adams, Elko Vosses, Andrew Schneider, Roderick van der Steen, Frank Campagna, Jace Retop, Norris Chu, and a big shout out, of course, to the co-author, Martin, who was there every step of the way putting this together. But on another note, there's probably 20, 30 effects which I showed. For every one of those, there's probably 50 which we didn't talk about because they worked so well that Martin and myself probably never even found out about them. They were put together by the creative, ambitious team in Amsterdam who built Horizon Forbidden West. And so on their behalf, I'd like to accept this award because they're the ones who built what we saw tonight. Thank you very much.
And that's a wrap for Real Time Live 2022. Be sure to join us tomorrow morning for our Real Time Live panel. And remember, there's no time like real time. In the meantime, make the most of it, and we'll see you next year.